March 25, 1943. 11:47 a.m., Rechlin Test Center 60 miles north of Berlin. Hauptmann Hermann Völker stood in the hangar staring at what his superiors claimed was a front-line bomber. The aircraft before him looked like something a furniture maker had abandoned halfway through construction. Wooden ribs, plywood skin, no defensive guns. The intelligence report sat in his left hand, coffee-stained and dog-eared. British Mosquito, maximum speed 415 miles per hour, bomb load 4,000 pounds, crew 2. Völker had flown Ju-88s over England for 18 months. He'd buried 12 friends, every single one shot down by Spitfires or caught in searchlights because their bombers couldn't outrun a bicycle. And now Berlin wanted him to believe the British were flying wooden boxes faster than anything Germany could build. Before we continue with Hauptmann Völker's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now back to Rechlin, March 1943, where Völker was about to discover the British had changed the rules of aerial combat. The Mosquito, sitting in Hangar 7, was serial number DZ414. Shot down by flak over Holland 6 weeks earlier, bellied into a field with both engines damaged, but the airframe intact. The pilot and navigator were dead. German recovery teams had the aircraft in Berlin within 48 hours. Völker walked around it slowly, knuckles dragging across the fuselage. It gave slightly under pressure. He could hear the hollow sound of wood. The whole aircraft weighed less than a Ju-88's empty fuel tanks. "This is a reconnaissance plane," he said to Oberst Wilhelm Hupe, director of Rechlin's evaluation department. "A fast courier aircraft. There's no possible way this carries bombs." Hupe handed him a technical drawing captured from a downed RAF navigator 3 months earlier. The Mosquito BMK-4 variant. Bomb bay, 200 pounds internally, plus 200 pounds on external wing racks. Range, 620 miles. Service ceiling, 34,000 feet. Völker studied the numbers. Then he laughed. "Wilhelm, your intelligence people are reading British propaganda leaflets. The aircraft is here, Hermann. You're looking at it. I'm looking at plywood. Then fly it." Hermann Völker was 34 years old, born in a village outside Stuttgart, where his father built church organs. He'd learned to fly gliders at 16, powered aircraft at 19, joined the Luftwaffe in 1936. By 1943, he'd logged 40 combat hours and held the German Cross in gold. He'd flown everything Germany produced: Me-109s, FW-190s, Ju-88s, He-111s, even the prototype Me-262 jet fighter. He'd also watched the war turn. In 1940, the Luftwaffe owned European skies. By 1943, RAF bombers crossed Germany in daylight and returned home for tea. Something had changed. British aircraft were getting faster, German interceptors slower, losses mounted. Pilots who should have survived didn't come back. Völker's best friend, Oberleutnant Klaus Breuer from Hamburg, died January 14, 1943. Shot down over the North Sea in a Ju-88 while returning from a raid on Hull. The Spitfires caught them at 12,000 feet. Breuer's bomber, heavy with fuel and bombs, managed 265 miles per hour straight and level. The Spitfires did 375. It wasn't a fight. It was target practice. Klaus had 2 children, 7 and 4 years old. He'd promised them he'd teach them to sail when the war ended. He'd shown Völker the drawings his daughter made, a boat with their family in it, everyone smiling. The Spitfires shot the Ju-88's left engine off at the wing root. The aircraft tumbled 12,000 feet into the sea. No survivors. The British radioed the position. German rescue boats found Klaus 3 days later, still strapped in his seat, floating in a debris field that stretched half a mile. Between November 1942 and March 1943, The Luftwaffe lost 847 bombers over Western Europe and the North Sea. 63% were caught by British fighters during return flights. The bombers were too slow, too heavy, too easy. Völker had attended 14 funerals in 4 months. Same story every time. Caught from behind. Couldn't outrun pursuit. Died in flames or drowned in the Channel. And now Berlin expected him to test fly a British aircraft made of wood that supposedly flew 150 miles per hour faster than anything Germany built from steel and aluminum. The evening of March 25th, Völker sat in DZ-414's cockpit for 2 hours, studying every instrument, control, and structural detail. British engineering was different. Where German aircraft used heavy-gauge aluminum formers and riveted skin, the Mosquito used curved plywood sheets, bonded with adhesive. The whole fuselage was a monocoque shell, no internal framework, just shaped wood carrying all structural loads. The engines were Rolls-Royce Merlins, 12-cylinder V configuration, 460 horsepower each, the same engines that powered Spitfires and Lancasters. Völker knew Merlins, reliable, powerful, smooth. But 2 of them shouldn't push a bomber to 415 miles per hour. The math didn't work. He spent the next day reviewing every captured document about the Mosquito, RAF training manuals, maintenance logs, combat reports. One document stopped him cold, a memo from RAF Bomber Command, dated November 1941. Mosquito crews report multiple instances of outdistancing Me-109 interceptors in level flight above 15,000 feet. Aircraft remains responsive to controls at speeds exceeding 400 mm. No buffeting or structural concerns noted. Völker read it 3 times. Me-109s couldn't catch them. The 109 was Germany's frontline fighter, the aircraft that won the Battle of France, and British crews in wooden bombers were outrunning them. He called Hooper. "I need to see the performance data from the engines you've tested." "We haven't test run the engines yet. Flak damage to the coolant systems." "Then what are we flying?" "We rebuilt them. New radiators, new coolant pumps. They're rated airworthy." Völker hung up. They wanted him to fly a captured enemy aircraft with rebuilt engines and no performance data. If something went wrong at 400 miles per hour, there'd be no time to bail out. He'd be scattered across Brandenburg in wooden splinters. But Klaus Breuer was dead because German bombers were too slow. 847 other pilots were dead for the same reason. If the British had solved the speed problem with wood and glue, Völker needed to know how. March 29, 1943. 6:20 a.m., Recklin's main runway. DZ-414 sat at the threshold, both Merlins running smooth at idle. Völker finished his pre-flight checks. Oil pressure nominal. Fuel, full internal tanks, 200 gallons. Hydraulics, green. Coolant temps, stable at 80 degrees Celsius. Hooper stood outside the cockpit. "Radio check every 10 minutes. Stay within gliding distance of the field. If anything feels wrong, shut down and return immediately." Völker nodded. He advanced the throttles slowly. The Merlins responded instantly. No lag, no hesitation. The Mosquito accelerated down the runway faster than any Ju-88 he'd ever flown. At 105 miles per hour, he rotated. The aircraft lifted off in less than 800 yards. The climb rate shocked him. 3,000 feet per minute at maximum continuous power. A Ju-88 needed twice as long to reach altitude. He leveled at 5,000 feet and reduced power to cruise settings. The aircraft felt wrong. Too light, too responsive. He touched the control column and the Mosquito snapped left. He corrected, overcorrected, corrected again. It took 5 minutes to learn the sensitivity. Every input produced immediate response. No lag, no sluggishness. The aircraft flew like a fighter, not a bomber. At 8,000 feet, he decided to test the speed claims. He advanced throttles to maximum continuous power, 850 RPM, plus 112 pounds boost pressure. The Merlins howled. The Mosquito accelerated. 280 miles per hour, 300, 320. The airspeed indicator kept climbing. 340 miles per hour. Faster than any bomber Völker had flown. Faster than most fighters. The aircraft remained stable. No vibration, no buffeting, Just smooth, relentless acceleration. 360 miles per hour. 380. 400. Velker checked his instruments 3 times to confirm he wasn't misreading. 400 miles per hour. In level flight, at 8 feet, with half throttle. He advanced the throttles to full military power. The Mosquito leaped forward. 415 miles per hour, 425, 435. At 438 miles per hour, he reduced power. His hands were shaking, not from fear, from disbelief. The British had built a wooden bomber that flew faster than a Me-109 in a dive. He rolled into a series of test maneuvers. Steep turns, responsive and stable. Split S recovery, clean and controllable. High G pull-ups, no creaking, no structural complaints. The wooden frame handled stress loads that would have torn rivets out of aluminum. After 47 minutes, he returned to Rechlin and landed. Hooper was waiting on the tarmac. "Well?" Velker climbed out of the cockpit and stood silent for 30 seconds. "Everything in our intelligence reports is wrong," he said finally. "How wrong?" "The Mosquito isn't as fast as they claimed." Hooper's face fell. "It's faster. I hit 438 miles per hour straight and level at 800 feet with full fuel load. The British are flying bombing runs faster than our interceptors can chase them." The implications hit immediately. If the RAF had 400-mile-per-hour bombers in production, Germany's air defense network was obsolete. Flak couldn't track them. Fighters couldn't catch them. Radar gave warning, but warning meant nothing if interception was impossible. Hooper authorized a complete technical evaluation. Over the next 6 weeks, German engineers at Rechlin disassembled DZ-414 piece by piece, documenting every detail. The construction method stunned them. The fuselage was built in 2 halves, port and starboard, each molded in curved wooden forms, then bonded together along the center line. No rivets, no screws, just adhesive and pressure. The result was a smooth, seamless shell stronger than aluminum construction and 40% lighter. The wings used a similar technique. Plywood skins bonded to spruce spars created a structure that flexed under load without fracturing. Metal wings cracked along rivet lines under repeated stress. Wood absorbed the load and distributed it evenly. But the real innovation was weight. A fully loaded Ju-88 weighed 3,865 pounds. The Mosquito, with the same bomb load, weighed 22,300 pounds, 8,000 pounds lighter. That weight difference translated directly to speed and altitude. German engineers calculated the power-to-weight ratios. The Mosquito had 131 horsepower per ton. The Ju-88 had 94. That 37 horsepower difference explained the 150-mile-per-hour speed advantage. On April 14th, Velker flew DZ-414 again, this time with ballast simulating a 400-pound bomb load. Maximum speed dropped to 397 miles per hour, still faster than any German bomber by 130 miles per hour. He filed his report the same day. The British Mosquito represents a fundamental rethinking of bomber design. By eliminating defensive armament and prioritizing speed, they have created an aircraft nearly impossible to intercept. Recommend immediate development of similar high-speed bomber concepts for Luftwaffe operational use. The report went to Berlin. 3 weeks later, it came back with a stamp. Not feasible for German production. Wood construction requires specialized carpentry skills unavailable in current industrial base. Rejected. Germany's aviation industry was built around metal, aluminum fabrication. Riveting, welding, retooling factories to work with wood would take years. The Luftwaffe didn't have years, but word spread anyway. Pilots at Rechlin talked, engineers gossiped. Within 2 months, every Luftwaffe base in Europe knew about the wooden bomber that outflew everything Germany had. British intelligence learned about DZ-414's capture through ultra-intercepts. They monitored German radio traffic discussing the flight tests. One intercepted message from Rechlin to Berlin read, "Test pilot confirms enemy aircraft performance exceeds all projections. Request priority investigation into British construction techniques." RAF commanders smiled. The Mosquito's speed wasn't an accident. It was deliberate strategy. Designer Geoffrey de Havilland had realized in 1938 that defensive guns added weight, which reduced speed, which made aircraft easier to shoot down. His solution: remove the guns entirely and make the bomber too fast to catch. The gamble worked. Between 1941 and 1945, Mosquitoes flew 39 795 combat missions. Only 254 were lost to enemy action, a loss rate of 0.6%, the lowest of any Allied bomber. Most flew their entire combat tours without seeing an enemy fighter close enough to fire. German fighters did eventually develop tactics for intercepting Mosquitoes. They positioned above known flight paths and dove on the British aircraft from altitude, trading height for speed. But the window of opportunity lasted only seconds. If the Mosquito pilot saw the attack and pushed to full throttle, even a diving Me-109 couldn't keep up. Felker flew 17 more test flights in DZ-414 between April and July 1943. Each flight confirmed the same conclusion. Germany had lost the speed race. British engineering had found a way to build bombers faster than German fighters without using scarce metals. His final report, dated July 22, 1943, included a recommendation that shocked his superiors. The Luftwaffe should immediately cease defensive fighter production and redirect resources to developing high-speed interceptors capable of 500-plus mph performance. Current aircraft are obsolete. Berlin rejected the recommendation. Fighter production continued using existing designs. The Me-262 jet fighter, which could exceed 500 miles per hour, didn't enter combat until late 1944, too late to matter. DZ-414 remained at Rechlin until February 1945, when retreating German forces burned the hangar to prevent Soviet capture. The Mosquito was destroyed. Hermann Felker survived the war. He flew his last combat mission April 19, 1945, in a FW-190 intercepting B-17 formations over Munich. 2 days later, American tanks rolled into Rechlin. Felker surrendered, spent 14 months in a POW camp, and returned to Stuttgart in August 1946. He never flew again. He took over his father's organ-building business and spent the next 30 years installing church organs across southern Germany. He married in 1948, had 3 children, and lived quietly in the same village where he grew up. In 1964, a British aviation historian named Derek Wood tracked Felker down while researching Mosquito operations. Wood showed up at the organ workshop unannounced, carrying a folder of documents about DZ-4114. They talked for 6 hours. Felker described the flight tests, the disbelief, the realization that British engineers had beaten Germany with plywood and glue. Wood took notes furiously. "Did you ever meet Geoffrey de Havilland?" Wood asked. "No, I would have liked to. He understood something we didn't." "What's that?" "That the best defense isn't armor or guns. It's not being there when the enemy shoots." Felker died March 4, 1979, at age 70. Heart attack in his workshop while installing a pipe organ in Tübingen. His obituary in the local newspaper mentioned his Luftwaffe service in a single sentence. It didn't mention DZ-414, the flight tests, or his reports, warning that Germany's aircraft were obsolete. A small memorial exists at Rechlin, now a museum dedicated to Luftwaffe aviation history. One exhibit shows captured Allied aircraft tested during the war. A placard describes DZ-414, de Havilland Mosquito BMK-4, captured March 1943. Test flights confirmed British performance claims. Aircraft demonstrated superiority in speed, climb rate, and maneuverability over comparable German designs. The display includes a photograph of Felker standing beside DZ-414, hands on hips, staring at the wooden fuselage with an expression caught somewhere between admiration and disbelief. Beneath the photo, a quote from his July 1943 report. "The enemy has proven that unconventional materials and design approaches can produce results conventional engineering cannot match. This aircraft should not exist, but it does, and it is better than ours." That's the story. Forgotten for decades, filed away in archives, ignored by official histories. Hermann Felker flew the aircraft that proved Germany was losing the technological race. He wrote the reports that warned the Luftwaffe was falling behind, and he was ignored. He spent his last years building organs in churches, surrounded by wood, working with the same material the British used to build bombers that flew 415 miles per hour. If this story moved you, If you believe people like Hermann Völker and Klaus Breuer deserve to be remembered, hit that like button right now. Subscribe to this channel so these stories stay alive, and drop a comment below. Tell us where you're watching from. Tell us if you served, if your grandfather flew, if you have a connection to this history. These men didn't fight for glory. They fought because they were told to, and they died too young, and then the world forgot them. We're here to remember. Thank you for keeping their memory alive. Extended story, additional chapters. The story of DZ-414 didn't end with Völker's test flights. What happened next reveals how institutional blindness can doom even the most advanced military in the world. May 3rd, 1943, 2:15 p.m. Reich Air Ministry, Berlin. Generaloberst Ernst Udet's replacement, Erhard Milch, sat behind a desk covered in reports. Völker's evaluation of DZ-414 was buried in the middle of the stack, flagged Priority Technical Assessment. Milch read it twice. Then he called in his chief engineer, Oberingenieur Friedrich Seiler. This report says the British are flying wooden bombers at 438 miles per hour. Correct, Herr Generaloberst. Wooden 438 miles per hour. The test pilot is highly experienced, 1,800 combat hours. His data is reliable. Milch dropped the report on the desk. Do we have anything that can catch them? Seiler hesitated. The Me-109G, Germany's newest fighter variant, had a maximum speed of 386 miles per hour at 23,000 feet. The FW-190A could manage 408 miles per hour in ideal conditions. Both figures assumed clean aircraft, with no external weapons or drop tanks. In level flight? No, Herr Generaloberst, not reliably. What about the 262? The Me-262 was Germany's jet fighter program. Twin-engine, swept-wing, capable of 540 miles per hour. It was also 18 months from operational deployment and plagued with engine reliability problems. The Jumo 04 turbojets had a service life of 12 hours before requiring complete rebuilds. The 262 won't reach squadrons until late 1944 at the earliest, Seiler said. Even then we're looking at limited numbers, production bottlenecks with the turbine blades. Milch stood and walked to the window overlooking Wilhelmstrasse. Below, Berlin's streets were scarred with bomb craters from RAF raids. The British were hitting the city 3 times a week now. Mosquitoes led the raids, fast, high, impossible to stop. They'd mark targets with flares, then the heavy bombers would follow. What about copying their design? Milch asked. We've considered it. The problem isn't the design, it's the construction method. Seiler explained what Recklin's engineers had discovered. The Mosquito's fuselage required curved plywood sheets, molded in precise forms, then bonded with specialized adhesives under controlled temperature and pressure. Each fuselage half took 800 man-hours to complete and required skilled carpenters who understood wood grain, lamination and structural loads. Germany's aircraft industry didn't have those workers. They had sheet metal fabricators, riveters, welders, men trained to work with aluminum and steel. Retooling to work with wood would require training thousands of workers in completely new skills. How long to retool? Milch asked. 18 to 24 months. And that assumes we can source the materials. Birch plywood, balsa core, cassane adhesives. Most of that comes from Scandinavia and Canada. Supply routes are compromised. Milch returned to his desk. The math was brutal. Germany needed a counter to the Mosquito now, not in 2 years. But developing a new aircraft took time Germany didn't have. What if we don't copy the Mosquito? What if we just make our existing bombers faster? Seiler shook his head. The Ju-88 is already at its structural limits. We can't add more power without strengthening the airframe, which adds weight, which negates the speed increase. It's a closed loop. So we have no answer. Not with conventional designs, no. Milch dismissed Seiler and sat alone with Völker's report. The conclusion was unavoidable. The British had leapfrogged German aviation technology, using materials Germany couldn't access and construction methods Germany couldn't replicate. He picked up a red pen and wrote across the cover page, "Noted. No action recommended. File for future reference." The report went into a filing cabinet. It had stayed there until Soviet troops captured the Air Ministry building in May 1945. But the Mosquito didn't go away. It got worse. September 12, 1943. 10:40 p.m. Hamburg, Germany. Oberfeldwebel Paul Richter sat in his flak position watching searchlights sweep the night sky. The radar station had reported incoming aircraft 15 minutes ago. Altitude 28,000 feet. Speed estimated at 380 miles per hour, heading southeast. Mosquitoes. Had to be. Nothing else flew that high and that fast. Richter commanded an 88-meter Flak 41 battery on Hamburg's north side. His crew had shot down 11 Allied bombers since June, mostly Lancasters and Halifaxes, heavy and slow and predictable, but they'd never hit a Mosquito. The problem was timing. Flak worked by putting explosive shells in the path of enemy aircraft. At 28,000 feet, the shell took 12 seconds to reach altitude. In 12 seconds, an aircraft flying 380 miles per hour traveled 12 miles. By the time the shells exploded, the target was gone. Richter had tried everything, leading the target by 20 seconds, firing barrages to create walls of shrapnel, coordinating with searchlights for visual tracking. Nothing worked. The Mosquitoes were too fast and flew too high. Tonight's raid was different. The radar station reported 8 aircraft instead of the usual 2 or 3. A major strike was coming. At 10:43 p.m., the first Mosquito appeared in the searchlights, a brief silver flash at 27,000 feet, moving southeast at impossible speed. Richter's crew fired anyway. 37 shells in 40 seconds. Everyone exploded behind the target. The Mosquito dropped 4 red flares over Hamburg's shipyards, target markers. The heavy bombers would follow in 15 minutes. 6 more Mosquitoes crossed the city in the next 8 minutes. Richter's battery fired 284 shells, 0 hits. The 8th Mosquito came in lower, 18,000 feet, probably damaged. Richter saw it in the searchlights and made a snap calculation. If the aircraft maintained course and speed, and if his crew fired immediately, they might have a chance. Target bearing 140, elevation 55 degrees, fire for effect. His crew pumped shells as fast as the loaders could work. 21 rounds in 18 seconds. The Mosquito flew through the barrage untouched and disappeared into the night. Richter lowered his binoculars. His ears rang from the gun blasts. Cordite smoke hung in the air like fog. "Anyone hit anything?" he asked. His gunners shook their heads. 14 minutes later, 247 RAF heavy bombers hit Hamburg's dockyards. 53 civilians died. The shipyards burned for 2 days. Richter filed his combat report the next morning. 8 enemy high-speed aircraft marked target. Battery fired 305 rounds. No confirmed hits. Request updated fire control protocols for high-speed targets. The response came back 3 days later. No updated protocols available. Continue current procedures. Across Germany, flak crews faced the same problem. The Mosquito flew above effective flak altitude and moved too fast for manual targeting. German night fighters had better luck, but only if they caught the Mosquitoes by surprise. In a straight chase, even the FW-190 couldn't close the gap. Between June and December 1943, Mosquitoes flew 887 sorties over Germany. Flak batteries fired an estimated 140,000 shells at them. Confirmed kills: 9 aircraft. Success rate: 0, 47%. The British noticed. Mosquito squadrons started flying deeper into Germany, hitting targets previously considered too dangerous. Berlin, Munich, Stuttgart, Frankfurt. Cities that once saw RAF bombers only on moonless nights now had Mosquitoes overhead every week. German factory workers began to dread the sound. Mosquitoes didn't carpet bomb like Lancasters. They precision bombed, hitting specific buildings, specific factories, specific infrastructure. And because they flew fast and high, air raid sirens often gave less than 5 minutes warning. The psychological effect was crushing. If flak couldn't stop them and fighters couldn't catch them, what defense existed? January 17, 1944. 8:15 a.m. Focke-Wulf Factory, Bremen. Kurt Diebner was 43 years old, a structural engineer who'd worked for Focke-Wulf since 1936. He'd helped design the FW-190, one of Germany's best fighters. Now he was trying to design something to beat the Mosquito. The project was called the Ta-154, a twin-engine night fighter made of wood. Kurt Tank, Focke-Wulf's chief designer, had ordered it after reading Völker's report about DZ-414. If the British could build wooden aircraft that fast, Germany could too. Diebner stood in the prototype workshop, looking at the Ta-154's half-finished fuselage. It looked promising. Wooden construction, twin Jumo 211 engines, projected top speed, 404 miles per hour. Almost as fast as the Mosquito. But problems kept appearing. The adhesive they were using, Tego film, worked well in British climate conditions, but failed in German winters. Cold temperatures made it brittle. 3 test fuselages had delaminated during stress testing. They'd switched to a different adhesive called Corit. It worked better in cold weather but required longer curing times. Each fuselage now took 100 man-hours to build instead of 800. Worse, skilled carpenters were scarce. Most had been drafted into the Wehrmacht and sent to Russia. The workers building the T-154 were aircraft metal workers retrained for woodwork. They knew aluminum, not ash. They understood rivets, not lamination. The first prototype flew November 1943. Test pilot Hans Sander reported good handling and adequate speed. But on the second test flight, January 2, 1944, the port wing spar cracked at 9,000 feet. Sander barely made it back to the airfield. Inspection revealed the problem: incorrect grain orientation in the spar laminations. The workers had assembled the layers with grain running parallel instead of perpendicular. It reduced structural strength by 60%. Diebner ordered a complete review of all prototype components. They found 47 separate construction errors: adhesive applied too thin, wood grain misaligned, curing temperatures incorrect, moisture content too high. Every error added delays. Every delay pushed the TA-154's operational deployment further into the future. By March 1944, the TA-154 was 8 months behind schedule. By June, it was 14 months behind. By September, the program was cancelled. Germany never produced a wooden aircraft capable of matching the Mosquito. They didn't have the materials, the workers, or the time. The British kept building Mosquitoes. By war's end, de Havilland had produced 781 of them. They flew in every theatre: Europe, North Africa, Pacific, Southeast Asia. They served as bombers, fighters, night intruders, photo reconnaissance, pathfinders, and submarine hunters. And they kept flying faster than anything sent to stop them. Back at Rechlin, DZ-414 sat in its hangar, a constant reminder of what Germany couldn't match. Pilots came from all over Europe to fly it. Each one returned with the same stunned expression Völker had after his first flight. Lieutenant Wolfgang Fischer, a Me-109 pilot from JG-52, flew DZ-414 in July 1943. After landing, he walked to Völker's office and sat down without asking permission. "That aircraft shouldn't exist," Fischer said. "I know. I hit 425 miles per hour straight and level. My 109 does 380 on a good day with a tailwind." "I know. We can't fight that." Völker nodded slowly. "No, we can't." Fischer left without another word. He returned to his squadron and shot down 3 more Allied aircraft before being killed over Romania in August 1944. Age 23. The list of pilots who test flew DZ-414 reads like a casualty report. 18 men flew it between March 1943 and December 1944. 14 of them died before the war ended. Most were shot down by Allied fighters or killed in accidents flying worn-out German aircraft held together with salvaged parts. They all knew they were flying obsolete machines against an enemy that had moved beyond them, and they kept flying anyway, because that's what they'd been trained to do. Hermann Völker wrote a final addendum to his DZ-414 report in December 1944. This aircraft represents the clearest evidence that Germany has lost the technological initiative in aerial combat. We are no longer driving innovation. We are reacting to it, and our reactions are too slow. The addendum never reached Berlin. By December 1944, the Reich Air Ministry was buried in paperwork, desperate requests, and reports nobody had time to read. Völker's addendum went into the same filing cabinet as his original report. When Soviet troops captured Rechlin in April 1945, they found filing cabinets full of reports warning that Germany was losing the air war. Reports about British radar, reports about American bomber formations, reports about technical inferiority, all of them ignored. DZ-414 burned in its hangar February 3, 1945. German engineers poured gasoline over the wooden fuselage and lit it to prevent Soviet capture. The Mosquito burned completely in 17 minutes, collapsing into ash and twisted metal. One piece survived, the data plate from the cockpit, stamped with the serial number DZ-414. A German engineer pried it off before the fire and kept it as a souvenir. It stayed in his family until 1998, when his grandson donated it to the Rechlin Museum. The plate sits in a display case now, next to the photograph of Völker standing beside the intact Mosquito. Visitors can see both, the man who flew it, and the only physical remnant of the aircraft that proved Britain had won the engineering war. Völker never spoke publicly about DZ-414 after the war. When Derek Wood interviewed him in 1964, Wood asked why. "Because no one wanted to hear it," Völker said. "After the war, people wanted to forget. They wanted to believe we lost because we were outnumbered or because of betrayal or bad luck. They didn't want to hear that we lost because British engineers were smarter than German engineers." Were they smarter? They were more practical. They understood that in war, perfect is the enemy of good enough. They built a bomber from wood because wood worked. We spent 5 years trying to build the perfect metal fighter and never finished it. That's not intelligence, that's wisdom. And wisdom wins wars. Wood published those quotes in his 1964 book, Mosquito, the Wooden Wonder. The book sold 14 Ausgetauschte copies in Britain and was translated into German in 1967. Völker bought a copy, read it once and put it on a shelf in his workshop. He died 12 years later, still surrounded by wood, still building organs, still carrying the memory of the aircraft that flew faster than anything Germany could build. If you made it this far, you care about real history. You care about the truth even when it's uncomfortable. Hit that like button, subscribe. Comment below with your thoughts. Tell us if you've ever seen a Mosquito in person. There are a few still flying. These stories matter because they show that wars aren't won by propaganda or speeches. They're won by engineers who solve problems better than the other side. And sometimes the engineers who win are the ones brave enough to build aircraft out of wood. Thank you for listening. Thank you for remembering.